Good evening, friends. The topic that I am going to discuss today is the components that are required to run a typical electrophoresis unit. But before going into the details, let us first understand the principle behind electrophoresis. This technique is based on the principle that any charged molecule or ion migrates when placed in an electric field. The rate of migration of this compound depends on its net charge, size, shape, and the applied current. This can be represented with the help of following equation. V equal to E into Q divided by F, where V is the velocity of migration of molecule, E is the electric field, F is the frictional coefficient, which is the friction of the mass and shape of the molecule, and Q is the net charge on the molecule. There is also a term called as electrophoretic mobility, which is very important in electrophoresis. The movement of charged molecule in an electric field is often expressed in terms of electrophoretic mobility, which is defined as the velocity per unit of electric field. It is denoted by the help of following equation. M equal to V divided by E, where M is the electrophoretic mobility, V is the velocity, and E is the electric field. Molecules with different charge density migrates under the electric field at different rates and hence get separated. Now let us understand the components that are required to run a typical electrophoretic unit. If you are new to my channel and you have not yet subscribed, subscribe my channel and press the bell icon so that you can get all the latest updates of my new uploads. Now let us continue with the remaining part of the video. Electrophoresis unit consists of three components. First, a pair of electrodes. Second, we have the supporting matrix, and third, we have the buffer. Now let us understand each and every component in detail. First is the pair of electrodes. Electrodes generally used are of platinum for supplying current. Arrangement of cathode and anode is kept according to the nature of the sample. So the main motive of the pair of electrodes is to supply current. Second, we have the supporting matrix. Now let us understand the requirements and characteristics of supporting matrix. First, it should be chemically inert to the sample components. Second, it should give superior resolution. Third, it should be stable over a wide range of pH, temperature and ionic strength. Fourth, it should offer uniform distribution. And fifth, in the case of gel as a matrix, wide range of pore sizes should be made available. There are different types of supporting matrix that are used. First is main adsorbent paper. Second, we have cellular acetate strips. Third, we have agarose gel. And fourth, we have polyacrylamide gel. Now first is the main adsorbent paper. Paper is inexpensive and finer for resolving small molecules. But the separation of macromolecules such as proteins and nucleic acid on such support is poor. Second, we have the cellular acetate strips. Cellular acetate has acetic acid over it. It is much more homogeneous, but the separation of macromolecules such as proteins and nucleic acid on such support is also very poor. Third is agarose gel. It is a linear polysaccharide with average molecular mass of about 12,000 Daltons. Agarose is one of the components of agar, that is a mixture of polysaccharide isolated from certain seaweeds. The gelling properties is attributed to both inter and intramolecular hydrogen bonding within and between the long agarose chains. The pore size in the gel is controlled by the initial concentration of agarose, and smaller pore size are formed from higher concentration and larger pore size are formed from lower concentration. An advantage of using agarose gel is that gel being transparent, it makes photoscanning possible. Now fourth is the polyacrylamide gel. Polyacrylamide gel is formed from the polymerization of acrylamide monomers in the presence of bisacrylamide, that is N,N-methylene bisacrylamide. Bisacrylamide consists of two acrylamide monomers linked by a methylene group. Pore size of polyacrylamide gels depends on the total concentration of acrylamide and bisacrylamide monomers in a fixed volume of gel solution. Gel ranging from 3 to 30% acrylamide solution can be used for separation of molecule of size up to 10 daltons. Another component, that is buffer. For proteins, buffer which is used is glycine in the upper reservoir and tris HCl of supporting matrix. And for DNA, we use TAE or TBE, that is tris acetate EDTA buffer or tris borate EDTA buffer. Now let us understand the role of buffer in gel electrophoresis. First, on applying voltage, buffer constituents gets ionized. Second, these ionized molecules move towards opposite electrode and carry out solutes which ultimately get separated. If you found my video helpful, please like my video, share my video with your friends, subscribe my channel and comment on it if you have any doubt regarding the session. Cheers. Thank you.